Well, the outcrop's right there, but yeah, those are wolf tracks. Obviously not a dog. I'm the only tire tracks in here. So yeah, these are wolf tracks. Well, I'm gonna go right here. Here it is. Hello everyone, it's November 25th, 2022, and I'm gonna talk about this rock behind me. Now this outcrop, there's a lot of them through here, but this one's a little unique. Here, what we have is older igneous rock here, and this rock is a light greenish gray. When I say that, I mean geologist green, as Sarah so likes to call it, and it's porphyritic. This was my unit 1 in my field notes here, and I even drew a little outcrop of what's behind me. But that's not what's interesting here, and I think this is Archean. And you can see this rusty stuff here is basically the same stuff, just rusted. But you look up here and you see the sharp fracture break, if you will, right up there. But this isn't what's really interesting. Above that is what's interesting. It's banded iron formation, or BIF for short. And it is not on the opposite side of the road. I went to the opposite side of the road over there, and the rock looks metasedimentary. I thought this originally might have been on top, but it's just a weathering pattern. And I thought that you're gonna see something later. I thought that might have been the same as that, but it turns out the geology is a lot more simple than I was trying to make it out to be. But you look at the rock up here, and this part isn't magnetic. I'm gonna take you to a magnetic part here and talk about it a little bit. You can see how it's really highly deformed, undulating. A lot of compressive strength went into deforming it. And although the rock there is highly deformed, down a little bit it's less so, and it has more of a consistent trend of, it does have a net trend of north 26 west, 11 northeast on the north end of the outcrop. It's a little less deformed than it is here. This unit, unit 1, is about north 78 west, 34 northeast. So the dips are both northeast, but the strikes are distinctly different, even though they're both north or west. That can tell me some things about this. That tells me this does not intrude this. That is not an intrusive contact. Hold on a second. Wait a tick here. Hey, it's me, Future Steve. Hi. Now, what you're about to see is somebody who's supposed to be good at interpreting rock outcrops get it wrong. I came to this outcrop and I started to form a hypothesis as I was going, but I didn't have all the information, and I probably still don't. However, the second hypothesis I'm going to come to is probably the better one. Initially, you're going to see me come to a conclusion based basically off 2 lines of evidence, both at that porphyry BIF contact. You're going to see foliations and what I originally thought was a paleosol, but it isn't. Now watch this, watch me go through this process, which I will be very wrong, and eventually we're going to get to what I believe is the proper conclusion, and others have kind of come to the same conclusion that I have in the second hypothesis, at least the age relationships. As for what they've actually thought was going on, I don't know, because the stuff on the other side of the road doesn't look like anything on the side I studied, yet they have them mapped as the same thing. So let's get back to it. You look at it up over here, and on the south corner there, which I've done, you distinctly see a paleosol, if you will, a primitive chemically derived soil, because remember, that's Precambrian, and since that formed on an erosional surface with a paleosol, this has to be Precambrian, which means we don't have a soil like you think of when you think of soil or topsoil. It's a chemically weathered rock is what it is. There's nothing organic on the land to sit there and make a topsoil at the time. So we use that term a little differently, and you can kind of see foliations near the contact as well. So now we look at this, and now we know this is older than the banded iron formation, and the stuff on the other side of the road, which is black, has a trend of north 13 west, 21 southwest. So completely different than the stuff over here. And it looks meta-sedimentary. You see things like laminations and cross-laminations and stuff like that. So that's probably meta-sedimentary, which means what? Well, we don't have any of Unit 1 or Unit 2 over there. What does that mean? That means the Trans-Canada 17 in front of me, behind the camera, there has to be a fault under here somewhere. So we have that going through here, and I have no idea how old those rocks are, and they're not really that interesting. They're pretty common here, so I'm not going to go into them. I want to focus on this stuff. Now, as you go north, what I thought was a fault, just not that far from here, maybe 10 meters, the rock changes. This looks different, and I took samples of all this stuff, except for the stuff on the other side of the road. So if that was a fault there, it formed before the BIF was deposited. But as it turns out, what I have is a dike. It's dark, it's more aphanitic, this stuff's porphyritic, and I got the trend of it, and you do see the other side where you can actually see the contact, and this comes back in as porphyritic rock at the north end of the outcrop. Now at the very north end of the outcrop, there's something interesting. I have this little magnet here, 2-inch magnet, and you put it on the rock up here, the banded iron formation, nothing happens. It just slowly falls off. You put it here and it doesn't even stay, but you put it on the banded iron formation over there and it sticks. Now, what does that tell me? That tells me it has magnetite in it over there and a lot more of it. The banded iron on the north side is a little more pure, and you can plainly see the contact between this and that over on the north side. What I have is that, and I have this which is highly deformed, and none of this is deformed. See, now if you walk upon something like this and you see that, your immediate instinct is this intruded that. But we don't have any of this stuff over there. So we know we have a fault. So what happened? How come this got so deformed and this didn't? And neither did the dike that intrudes this, which I called Unit 3. The stuff back there is Unit 4. So a couple things could have happened. What you see here is you have some paleotopography, but you do see you have what looks like foliations in it at the contact in this unit, Unit 1. So what that tells us is there was some deformation here. You might have had some initial dip on the banded iron when it was deposited, but not a lot. So we had a compressional event here, and the fault underlying the road could have had something to do with that, but I doubt it. That's more brittle failure. Okay, let's stop right here. Now, I go into a little bit of an overcomplicated rationale to try to explain this deformed BIF on top of this undeformed porphyry. So that's when I start talking about here for a while, and I give a couple different scenarios about how that can be. And that was part of my first hypothesis, but like I've already said, that one isn't likely. So let's keep going, all right? And this whole thing buried, then was lifted up, probably during the Pinokian orogeny. I don't really know. I haven't seen this. Was deposited circa 2,700 million years ago. So order of events, to sum it up, Unit 1 here was deposited, however, during the Archean. Then Unit 3, the dike, intruded it at some point, if not already at that time, at the surface. It was lifted to the surface. You had this unconformity form. You get this little paleosol on top of it. The BIF gets deposited. This all probably happened 20, 30 million years time. Not a lot of time. And then later, you know, it got buried, deformed during the late Archean. And during the Pinokian, we had compression, so circa 1.85 billion years ago, 1850 million years ago, deforming this BIF before, after post-mid-continent rift, after the extension stopped, we got compression, bringing this back to the surface, essentially giving us what we have today. When you look here, I can see how you might think that right there, that Unit 1, this porphyry, intruded up into at least part of the BIF. Because you see like any other parts here, then you see that high folding, a little bit of brecciation. Now, could this still be an intrusion? Maybe. Like I said, there's that stuff over there that looks meta-sedimentary, which is probably younger than even the banded iron formation. But you come over here and our porphyry is in contact with this other unit 3, this dike, which doesn't trend this way. None of these cleavages or foliations trend with the dike contact, but that might be in line with the fault that I suspect is in the road right there. But I'm gonna come up here and see if I see this dike intrude any of the banded iron. And if I do see it, then I know our banded iron is older than at least unit 3. If I come over here, I don't see it. I don't see any banded iron over here. And we're not even to the bottom of the banded iron formation. It's actually probably about right there. Here's our contact. This is our unit 3. This is our unit 1, our porphyry. And you follow it up and it comes right up here. So, does it intrude the BIF? I could say yeah. So that throws a little wrench into everything we thought. Now, could that be a depositional contact? Yeah. But that steep and that sharp of an angle? Not likely. So this could have intruded much, much later. So, and then you get back to the BIF here, and this is where it's all magnetic. What is really going on here is hard to tell from the outcrop. See, and you come here, here's your porphyry, unit 1, right here, and this is where it's highly magnetic. See? This is non-magnetic. And you look at the contact here, and it looks like there's deformation here. So, unit 3 could have intruded unit 1 and unit 2. So the porphyry and the BIF. This kind of throws a wrench in it. Anyway, it's kind of really nice out. I like that. I think that's it for today. I don't think I'm gonna do anything else. I think I'm gonna turn around and go back to the Sioux. I'm still at the outcrop, but as much as I hate to say it, I can't continue. It is 12:35 CST now, and I don't have much daylight left. It's going to take me about 3 hours to get back, 2 hours, something like that. So I should turn around now and go back. The other sites will have to wait for a different day and a different time. Okay, quick summary. First hypothesis was that porphyry was intruded sometime before the BIF was deposited. Then erosion happened, exposed that porphyry to the land surface, and you had a paleosol. Then the BIF was deposited in a marine setting, which would require subsidence. Now, in that interpretation, later, the BIF became deformed. And I go through and stumble through possible ways of that happening, making this really complicated. Now, I did start to notice that as I was talking about that stuff and making that stuff really complicated, that maybe I was wrong. It's not necessary to make a complicated interpretation to explain this outcrop. The second hypothesis basically was this: the banded iron formation was deposited in a marine environment, and later that porphyry came and intruded it, and then so did the dike. Now, as I was walking along, and I initially did my rant in my first hypothesis, I started walking north, and then I saw what I thought was a fault between the porphyry and the BIF. And that wasn't a fault. That was a covered contact. That low valley area is actually where the dike is. And you see the other side of the dike in contact, fortunately. And if you weren't looking for it, you wouldn't see it. That dike, mineralogically, is almost identical to the porphyry. It's just more aphanitic or finer grained, and there's no phenocryst in it, indicating that that dike had the same magmatic origin as the porphyry. It just was later in the game, and it clearly intrudes that BIF. So, you know, law of cross-cutting relationships, that BIF had to be deposited before that dike. And since that dike is very similar in mineralogy to that porphyry also likely intrudes it. So, what about that foliation and that paleosol on top? Well, The foliation probably could have formed because I didn't do any detailed measurements on it until after I looked at the north side and came back. The foliation is kind of, I want to say, it's sub-parallel to the likely direction of intrusion. So those foliations on top, likely the way that magma body came through. And when it hit that BIF, you know, that topography corresponds with the deformed BIF above it. And then the BIF does get less deformed as you go up, and then it's just gone. So if more of that BIF were exposed, we'd probably generally see it become more level, and that would definitely solidify it as a, you know, intrusion, that porphyry. But what I thought was that paleosoil or geosoil, whatever you want to call it, actually was probably formed by later groundwater. The more you look at it, and from the pictures I took, it looks very black, like the hematite had rusted, not rusted out, but been transported or some other mineral through groundwater activity. That's probably how that formed, and that's why it has that big gap between the two, and the unconformity is so obvious now in outcrop, is because it's probably due to groundwater movement, because banded iron formation at the surface of the planet today in our oxygen-rich atmosphere is very susceptible to chemical weathering, not only at the surface like it is undergoing now, but also in the subsurface due to groundwater moving through it, especially oxygenated groundwater. I think that covers it. Anyway, that's it. If you have any questions or comments, please leave them below, and I hope you learned something.